At 8 o'clock on Saturday morning, the people of Tinian were told they were safe. The warning was lifted. The port at San Jose reopened to cargo traffic. The threat of tropical storm winds had passed to the north, and the message from the National Weather Service office in Guam was the one everybody in that island chain waits to hear during typhoon season. All clear. Go home. Open the shutters. Get on with the day. 7 hours and 47 minutes later, the ground under San Jose moved. Magnitude 4.9, 10 kilometers deep, almost directly beneath the village that had just been released from a storm warning that morning. And at the very same hour, 400 and something kilometers to the north, along the same chain of islands, under the same flag, a typhoon with sustained winds of 110 miles an hour was closing on a volcanic island called Agrihan, where the emergency instruction was not to shelter in a building, it was to shelter in a cave. One archipelago, one Saturday. Two disasters arriving from opposite directions, one out of the sky, one out of the seafloor. Here is what actually happened on August 22nd, 2026, hour by hour. Because the sequence is stranger than the headline, and there is one question buried inside it that a lot of people are going to get wrong. If you want the real version of days like this one, what the agencies measured, what they did not, and what it means for the week ahead, subscribing takes a second and puts every one of these breakdowns in front of you as they happen. Let me start where the day started. The Northern Mariana Islands are a curve of 14 volcanic peaks pushing up out of the western Pacific, strung north to south across roughly 700 kilometers of open ocean. Almost everybody lives on the three southern islands, Saipan, Tinian, and Rota, with a total Commonwealth population of somewhere near 43,000 people. The Northern Islands are a different world. Volcanic, mostly evacuated, reachable only by boat or small aircraft, and inhabited at any given moment by a handful of people. When the Weather Service issues a typhoon warning for Agrihan, Pagan, and Alamagan, it is not warning a city, it is warning individuals whose names the local agencies more or less know. Saudel had been building toward those islands for 3 days. It came together near the Truk Islands earlier in the week as an untidy, lopsided system that forecasters were openly unimpressed by. Its center was stretched out, its thunderstorm structure was uneven. On Thursday, the Japan Meteorological Agency had it as a tropical storm with sustained winds around 75 kilometers an hour and a central pressure near 996 hectopascals, which is to say, a storm, but not a monster. The forecast, though, said something different. It said the water and the air ahead of Saudel were about as favorable as the Pacific ever gets, and that this was a storm about to change character quickly. That is exactly what it did. By Saturday morning, the Weather Service in Guam was watching a system that had gone from around 111 kilometers an hour to roughly 176 kilometers an hour in 24 hours. That jump clears the formal threshold for what forecasters call rapid intensification. Satellite imagery showed a fresh eye opening at the center, about 37 kilometers across, with deep thunderstorm towers wrapped almost all the way around it. 24 hours earlier, the storm had no eye worth the name. Now it had a clean one. It is worth slowing down on what rapid intensification means, because it is the single most consequential thing a tropical cyclone can do to the people in front of it, and it is the thing forecasters are least able to promise. A typhoon is a heat engine. It takes warm water at the surface, converts it into rising moist air, releases enormous energy when that moisture condenses high up into cloud, and vents the exhaust outward at the top of the storm. If the exhaust vents cleanly and nothing tears at the structure from the side, the engine tightens. The center contracts. The winds accelerate inward like a skater pulling in her arms. And the whole system can go from unremarkable to dangerous inside a single day. Saudel had every input it wanted. Ocean temperatures of 30 to 31 degrees Celsius are near the upper end of what the tropical Pacific offers, and the depth of that warm layer matters as much as the surface reading, because a storm churns the water beneath it and will choke itself if it drags cold water up from below. Vertical wind shear, The difference in wind between low and high altitude that normally tilts and shreds a developing cyclone was running at only about 9 to 19 kilometers an hour. That is close to nothing. And the upper level outflow toward the pole was strong, meaning the exhaust had somewhere to go. Give a storm that combination, and it does not strengthen gradually, it steps. This is why the timing of a warning is often more important than the wording. A community that receives a forecast on Thursday describing a moderate tropical storm and then wakes up on Saturday to a system with a well-formed eye and 110-mile-an-hour winds has lost most of its preparation window without doing anything wrong. Forecast tracks have improved dramatically over the past 30 years. Forecasting how strong a storm will be and when it will make its jump remains one of the genuinely unsolved problems in the field. Saudel was a textbook illustration. The models flagged the possibility days out, and the storm still nearly doubled its wind speed in the final 24 hours before it reached the island chain. And crucially, the track had held steady. Since Friday, it had not wobbled. That is why the southern islands got their release. At 6:30 in the morning, the ports of Saipan and Tinian reopened to commercial and cargo operations under heavy weather condition whiskey. At 8, the all clear came for both islands. The tropical storm threat to the two most populated places in the Commonwealth was over. Dangerous surf and rough seas continued. Small craft advisories stayed up, but the wind threat had lifted and Saudel was going to run north of everybody who lives in a town. So by mid-morning on Saturday, the Marianas had split into two halves. In the south, 40,000 plus people going back to normal. In the far north, 3 islands under a typhoon warning and a Condition 1 alert, with the instruction to stay inside protective shelters or caves until somebody sounded the end of it. Then, at 3:47 in the afternoon local time, the second thing happened. The United States Geological Survey logged an earthquake of magnitude 4.9 near San Jose Village on Tinian at a depth of 10 kilometers. 10 kilometers is shallow. Shallow matters more than most people realize, and I will come back to why in a moment. But hold on to this. A magnitude 4.9 at 10 kilometers under a populated island is a very different experience from a magnitude 4.9 200 kilometers down. The energy has almost nothing to travel through before it reaches the floor of somebody's kitchen. Tinian is not a big place. Its population sits in the low thousands. San Jose is its main village on the southwestern shore, where the harbor is the same harbor that had reopened to cargo 9 hours earlier. A shallow magnitude 4.9 directly beneath that village is not a catastrophe. It is a hard, short jolt. Dishes move, doors swing, people stop talking mid-sentence and look at each other. In a chain of islands that averages something on the order of 280 earthquakes of magnitude 4 or greater per year, this is not an extraordinary event by itself. But I promise to explain why depth changes everything, so let me do that properly. Think of earthquake energy the way you would think of sound from a speaker in an apartment block. A speaker 200 meters down the street and a speaker directly under your floorboards can be putting out identical power, and the experience in your living room is not remotely the same. Rock absorbs and scatters seismic energy as it travels. Every extra kilometer of crust between the rupture and the surface spreads that energy out and takes some of it away. Which is why a magnitude 4.9 at 230 kilometers depth and the Marianas produce those routinely might not be felt by a single person, while the same magnitude at 10 kilometers under a village will be felt by everyone in that village and will be described afterward as a bang rather than a sway. 10 kilometers in this part of the world is essentially the surface. And that surface sits on top of the most extreme piece of architecture on the planet. Just east of these islands lies the Mariana Trench, where the Pacific Plate bends downward and dives beneath the Philippine Sea Plate. At the Challenger Deep, the trench floor lies nearly 11 kilometers below sea level. Drop Mount Everest into it, and the summit would still be more than 2 kilometers underwater. That trench is not a canyon carved by erosion. It is the visible seam where one piece of the Earth's outer shell is being consumed by another. The islands themselves are the byproduct of that process. As the descending slab sinks, water trapped in its minerals gets driven out under heat and pressure. That water lowers the melting point of the rock above it, magma forms, and it rises to build a chain of volcanoes running parallel to the trench. Every island in this chain, Saipan, Tinian, Alamagan, Pagan, Agrihan, exists because a plate is being swallowed a few hundred kilometers offshore. The volcanoes and the earthquakes are not two separate hazards that happen to share an address. They are two symptoms of the same machine. So when the ground moved under San Jose on Saturday afternoon, it was not an intrusion into an otherwise peaceful place. It was the place doing the thing that built it. It is the timing that makes people sit up. Because while Tinian was feeling that jolt, Saudel was in its final approach to the far northern islands. At 4 in the afternoon local time, the Joint Typhoon Warnings Center pegged the storm at about 176 kilometers an hour with a central pressure of 963 hectopascals. Sea surface temperatures underneath it were running between 30 and 31 degrees Celsius, call it 86 to 88 degrees Fahrenheit, warm enough that a swimmer would call the ocean bathwater. Wind shear, the atmospheric force that tears storms apart, was almost absent, and the significant wave height near the center was about 10 meters. 10 meters! Take the roof of a 3-story building and put it on the sea, moving. At 7 in the evening, the center of Typhoon Saudel was about 48 kilometers northwest of Agrihan. Maximum sustained winds had reached 177 kilometers an hour, which is 110 miles an hour, comfortably into what the Atlantic scale would call a Category 2 hurricane and pushing at the door of Category 3. Typhoon force winds extended 72 kilometers from the center. Tropical storm force winds reached out 241 kilometers. At 8 o'clock, the Commonwealth Emergency Operations Center issued a bulletin describing Saudel as passing over Agrihan. At 8:53, the Weather Service in Guam issued a local statement that put it slightly differently. It said the storm had passed close to the island with the center just to the northwest. I want to flag that discrepancy rather than smooth over it, because it is the kind of detail that gets flattened in most coverage. Two agencies, 53 minutes apart, describing the same moment, one saying over, one saying close to. Neither is wrong. That is what the fog of a real-time landfall looks like when the island in question has no radar, no dense observation network, and almost nobody on it to report from. The exact center position of a typhoon crossing an unpopulated volcanic cone is, in the hour it happens, an estimate. It gets nailed down later. What was not ambiguous was the forecast for the next several hours. West to southwest winds of 130 to 160 kilometers an hour, with gusts reaching 210 kilometers an hour. 210 kilometers an hour is 130 miles an hour. That is a gust that will take a corrugated roof off a structure and turn it into an airborne blade. Rainfall across the far northern islands was forecast at 200 to 300 millimeters through Sunday, with the possibility of more than 500 millimeters near the storm's core, though most likely over water. 500 millimeters is half a meter of water falling out of the sky in a day and a half. On a steep volcanic island with thin soil and no drainage engineering, that is not a rainfall statistic. That is every gully on the mountain turning into a chute. And the sea came with it. Coastal flooding of 0.3 to 0.9 meters was expected around Agrihan and Pagan, with significant erosion as Saudel-driven swell struck the reefs. Life-threatening surf along the south and east-facing shorelines was forecast to continue into Sunday. So that is the day. Now the question that matters, and the one I know is already circulating in comment sections and short-form clips, did the typhoon cause the earthquake? No, and it is worth spending real time on why, because the reasoning is more interesting than the answer. Here is the physical scale of it. A deep, powerful typhoon like Saudel drops the air pressure at the sea surface. Saudel's central pressure was measured near 963 hectopascals, against a normal sea level pressure of about 1,013. That difference sounds meaningful. Converted into force on the seafloor, it is about the weight of half a meter of extra water, and it is spread thinly across a very wide area, and it arrives slowly over hours. Now consider what a fault beneath the Mariana Arc is holding. The Pacific Plate is diving beneath the Philippine Sea Plate along the Mariana Trench, the deepest trench on Earth, plunging to nearly 11 kilometers at the Challenger Deep. That subduction is grinding rock against rock under kilometers of overlying crust, with stresses that accumulate over decades and centuries. The pressure locked into that system is larger than an atmospheric pressure change by something on the order of thousands to tens of thousands of times. Asking a typhoon to trigger that is like asking somebody to change the course of a freight train by breathing on it from the platform. There is a serious scientific literature on very small stress interactions, tidal loading, seasonal water loading, the tiny nudges that can, in certain settings, marginally shift the timing of an event that was already on the edge. Those effects are real. They are measurable in aggregate across enormous data sets, and researchers argue about them honestly. But that is a statistical whisper across thousands of earthquakes. It is not a mechanism by which a storm passing 400 kilometers north of an island produces a shallow magnitude 4.9 beneath that island the same afternoon. Nobody working on this in a serious capacity would make that claim, and you should be skeptical of anyone who does. Let me give the strongest version of the opposing argument, because it deserves better than a dismissal. Someone could reasonably say, fine, atmospheric pressure alone is trivial, but a typhoon does not only change pressure, it piles water. It generates 10-meter waves that pound a coastline for hours. It dumps hundreds of millimeters of rain onto steep terrain, which loads slopes and pushes water into fractured volcanic rock. Loading and unloading the crust is a real mechanism. It is why some regions show measurable seasonal patterns in small earthquake counts, and why reservoir filling has been linked to seismicity in specific documented cases. That argument is not stupid. It is just aimed at the wrong distance. Every one of those effects is concentrated where the storm is, and the storm on Saturday afternoon was hundreds of kilometers north of Tinian, closing on Agrihan. Tinian was not being loaded. Tinian had been under an all-clear since 8 that morning. The waves and the rainfall that could conceivably nudge anything were arriving at islands with no permanent villages, not at the one that shook. Geography kills that theory before physics has to. The honest explanation is much less cinematic and much more useful. The Marianas are one of the most seismically busy places on the planet, and they sit in one of the most typhoon-exposed corridors on the planet, and those two facts are entirely independent of one another. If a region records hundreds of magnitude 4 or greater earthquakes in a typical year, roughly one every day or two, and it also sits in the path of the Western Pacific typhoon season, then the two will overlap, not occasionally, regularly. The coincidence is not the anomaly. The coincidence is the arithmetic. What makes August 22nd worth a video is not a hidden connection. It is that this particular archipelago is where two completely separate planetary systems happen to have their busiest intersection, and this Saturday put both of them on the same page of the same log. I will admit something. When I first lined up the timestamps on this, my instinct was that I had found a pattern. It took me about 4 minutes with the base rate numbers to realize I had found a calendar. That is the part I want you to take away more than any wind speed. If you have ever felt an earthquake anywhere, any size, drop it in the comments with the place. I read those, and the geographic spread on a video like this one is always more interesting than the video. Now, let me take you to the Northern Islands themselves, because there is a human story here that almost never makes it into the coverage. Agrihan is a volcano. Not a place with a volcano on it, the island is the volcano, rising to the highest point in the entire Mariana chain with a summit crater and slopes that drop steeply into deep water. Pagan, its neighbor to the south, is two volcanoes joined by an isthmus and has been through evacuation and partial resettlement more than once. Alamagan is smaller and steeper again. These islands do not have hurricane-rated shelters. They do not have hospitals. They do not have a road network worth the word. Which is why the official instruction on Saturday evening was for residents of Alamagan, Pagan, and Agrihan to remain in protective shelters or caves until conditions eased and an all-clear was issued. Caves! In 2026, that is not a failure of emergency management, it is the geography being honest. On a steep volcanic island with a handful of residents, in the path of a Category 2 or 3 typhoon with 130-mile-an-hour gusts, lava tubes and rock overhangs are the strongest structures available, and people there know exactly which ones to use. That knowledge is generational. It is also, on a night like Saturday, the entire difference between an ordeal and a tragedy. There is something else in how this warning was handled that deserves credit. Days before any watch was posted, when Saudel was still an untidy storm near Truk, the Weather Service had already said publicly that watches would go up roughly 48 hours before tropical storm conditions began, and that a local statement would name Agrihan, Alamagan, and Pagan when it did. They were urging preparation and, specifically, communication with the few people known to be in the Northern Islands before there was a warning to issue. That is what good practice looks like in a place with almost no infrastructure. You cannot evacuate a volcanic island in 12 hours when the only way off it is a boat and the sea is already running at 10 meters. So the lead time has to come earlier, and the message has to reach individuals rather than broadcast to a population. By the time the typhoon warning went up, the people it applied to had been in the loop for days. If you take one practical thing from this, the value of a warning is not in the moment it is issued. It is in the hours you already spent assuming it might be. And this is not the first time this year that this chain has had to use that knowledge. Back in April, Typhoon Sinlaku tore through the Marianas and did serious damage on Saipan, knocking power out for tens of thousands of people across the islands. 12 deaths were confirmed across Micronesia and the Marianas from that storm. 4 months later, the same chain took a typhoon warning again. That is the rhythm of life out there, and it is worth remembering when a place like this shows up in a news cycle for one afternoon and then vanishes from it. So what happens next? 3 things are moving, and they are on 3 different clocks. The first clock is Saudel itself, and it is running fast. When the storm cleared the Northern Marianas, it was not finished strengthening. It was barely getting started. The Joint Typhoon Warning Center forecasts Saudel to reach roughly 240 kilometers an hour, which is about 150 miles an hour, by Sunday evening and to hold near that intensity into Monday. The Japan Meteorological Agency forecast a minimum central pressure near 925 hectopascals, with sustained winds near 180 kilometers an hour by Monday. Both agencies had it tracking west-northwest toward the Ryukyu Islands, with Okinawa in the frame around Wednesday. The intensity guidance, though, is split, and this is where honest forecasting looks messy on purpose. The rapid intensification models pointed toward a possible peak, somewhere between 260 and 280 kilometers an hour. Other guidance topped out closer to 195 to 205. The official forecast of 241 leaned toward the aggressive end. That is a spread of nearly 100 kilometers an hour between the models, on the same storm, on the same day, and no forecaster on Earth can tell you today which side of it Saudel will land on. Track confidence follows the same shape. High confidence through 3 days, medium beyond that. The cross-track model spread grows from about 232 kilometers at 72 hours out to about 315 kilometers later in the period. In plain terms, the general direction is settled, and the specific arrival point over the Ryukyus is not. If you have people in Okinawa, in Amami, in the southern islands of Japan, the useful move is not to fixate on a forecast line drawn today. It is to watch the updates through the middle of the week, because that line will move. The second clock is slower, and almost nobody outside the region is watching it. There is a separate rainfall threat forming behind Saudel. The Weather Service flagged a disturbance northwest of Yap combined with a surge of southwest monsoon moisture capable of driving locally heavy rain from Guam northward to Rota. A hydrologic outlook put 100 to 180 millimeters of rain across Guam, Rota, Tinian, and Saipan starting around Tuesday, with rising flooding and mudslide potential. Read that carefully. The islands that got their all clear from the typhoon on Saturday morning are the islands lined up for the flooding threat by the middle of the week. The wind danger and the water danger were never the same danger. Wind gets the headlines because wind is visible and wind has a number attached to it. Water kills more people. A saturated hillside above a village does not announce itself with a satellite image. The third clock is the one under everybody's feet, and it does not have a forecast at all. The Mariana subduction zone will keep producing earthquakes on Sunday, on Monday, and every week after, at a rate the region has run at for as long as anyone has been measuring. Most will be too small or too deep to feel. A few each year will be large enough to rattle the southern islands. The historical record through this arc includes events well up into the magnitude 6 and 7 range, a magnitude 7.6 in 2016, a magnitude 6.9 near the Maud Islands in 2023. Saturday's magnitude 4.9 belongs to the ordinary end of that distribution, and the arc is doing other things too. Just last month, unrest at the Ahi Seamount, a submarine volcano in the northern part of this same chain, was significant enough that observers raised the question of whether activity might break the ocean surface. That is a different hazard again, on a different timescale, in the same 700 kilometers of ocean. So here is what August 22nd really shows you, once you strip the coincidence out of it. There is a curve of islands in the Western Pacific, home to fewer people than a mid-sized town, sitting directly on top of the deepest trench in the world and directly inside the busiest typhoon corridor in the world. It does not need a conspiracy to have a violent Saturday. It only needs a Saturday. What made this one memorable is that the two threats arrived close enough together to be seen in a single frame. The sky one had a name, a forecast track, and 3 days of warning. The ground one had none of that, arrived without notice, and lasted a few seconds. That contrast is the real story, not that they are connected, but that one of them we can see coming and the other one we cannot. The next thing to watch is specific, and it is close. Watch the Wednesday guidance on Saudel as it approaches the Ryukyus, and watch whether the storm verifies at the aggressive end of that model spread or the conservative one, because that answer will tell you a great deal about how well the rapid intensification tools are performing this season. And watch the rain totals across Guam and the Southern Marianas from Tuesday onward, because that is the threat with the higher body count and the lower profile. I will be tracking both. If you want the next update the moment those numbers land, subscribe and hit the bell. This storm has 4 more days of forecast to run, and the part that matters most has not happened yet.